Hello, space enthusiasts and curious minds. Welcome back to our channel, where we explore the most astonishing discoveries in the universe. Today, we're diving into a remarkable event captured by the James Webb Space Telescope, JWST, an asteroid collision in a neighboring star system. Make sure to stay tuned as we break down this cosmic phenomenon into 5 detailed segments. Europa, one of Jupiter's moons, remains intriguingly warm despite its orbit far outside the Goldilocks zone. This warmth can be attributed to the energy it receives from Jupiter and the other moons that share its orbit. Astronomers have been captivated by Europa since its discovery in 1610, and their fascination only grew after hints of a sub-ice ocean emerged during the Voyager missions of the late 1970s. It took decades of meticulous research, culminating in a groundbreaking 10-hour observation by the James Webb Space Telescope to peel back some of Europa's icy secrets. What did this extensive study reveal? Could it possibly hint at life beyond our planet? Join us as we delve into the James Webb Space Telescope's marathon observation of Europa, exploring how this mission may have uncovered signs of life. Europa is not just another moon, it's one of Jupiter's largest, alongside Io, Ganymede, and Callisto, collectively known as the Galilean moons, first spotted by Italian astronomer Galileo Galilei in January 1610 using a homemade telescope. Predominantly composed of silicate rocks, Europa's icy surface might just conceal more than meets the eye. Beneath the frozen expanse of Europa lies a secret world, with an iron-nickel core encased in a thick shell of water ice. This moon of Jupiter breathes a thin atmosphere, primarily composed of oxygen, marked by striking dark reddish-brown fissures that scar its icy surface. Geologically youthful, the surface of Europa is estimated to be between 40 and 90 million years old, a mere blink in cosmic time. Beneath this frigid crust, an expansive ocean of salt water lurks, holding twice the volume of Earth's oceans. This subterranean sea is not only vast, but could potentially harbor the essential chemicals necessary for life. The possibility that Europa could be one of the best candidates for extraterrestrial life within our solar system has ignited the scientific community and captured the imagination of many. For decades, science fiction has speculated about alien life flourishing in these hidden depths. Now, that fiction edges closer to reality as Europa stands at the forefront of our quest for life beyond Earth. The excitement isn't confined to just the scientific community, it's a growing intrigue shared by many around the world. Could the dreams of discovering extraterrestrial life be rooted in the truths hidden beneath Europa's icy facade? Spectroscopic analysis continues to fuel these hopes, bringing us closer to answering one of humanity's most profound questions. In 1972, telescopic observations at Kitt Peak National Observatory in Tucson, Arizona, unveiled that Europa's exterior is predominantly composed of water ice. Thermal models from a year prior suggested an even more thrilling possibility, a hidden layer of liquid water at its core. As the 1970s progressed, the Pioneer 10 and 11 spacecraft whizzed past Jupiter, setting the stage for more detailed explorations. It was Voyager 1 and Voyager 2 that truly brought Jupiter's moons into focus, capturing the first high-definition images from a breathtaking distance of between 1.2 and 2 million kilometers. On March 4, 1979, Voyager 1 made a close approach to Jupiter, snapping detailed photos of Europa. A few months later, on July 9th, Voyager 2 followed suit, zooming past Europa and providing even closer views. The images from the Voyager missions revealed a moon that outshone its siblings in brightness, adorned with a tapestry of bands and ridges. Remarkably, Europa displayed few large impact craters, high cliffs, or mountains, indicative of a surprisingly smooth surface. The sparse impact scars hinted at a young surface, continually reshaped by processes like cryovolcanism or the shifting of its icy crust. This intriguing smoothness fueled anticipation for NASA's Galileo mission, which launched in 1989 and entered orbit around Jupiter in 1995. Galileo's primary mission was to provide an unprecedented close-up view of this enigmatic moon, adding layers to our understanding of Europa's dynamic environment and its potential for hosting life. The Galileo spacecraft's encounter with Jupiter's moons was so compelling, particularly its observations of Europa, that it prompted an extended mission known as the Galileo Europa mission. This additional exploration, lasting 2 years, allowed the spacecraft to make 12 close passes of the icy moon, each one unveiling more of its secrets. One of Galileo's most significant discoveries was a variation in Jupiter's magnetic field around Europa. This anomaly was traced back to a thick layer of electrically conductive fluid beneath Europa's icy surface, likely creating a unique magnetic signature. Scientists posit that this signal could be emanating from a vast ocean of salty water, concealed beneath Europa's icy shell, which ranges from 10 to 25 kilometers thick. Despite Europa being only about a quarter the size of Earth, this hidden ocean could contain twice the volume of all Earth's waters, making it an extraordinarily promising location in the search for extraterrestrial life. While the Galileo mission in the 1990s didn't observe any water plumes, subsequent analyses and observations, including those from the Hubble Space Telescope, suggest the presence of thin plumes of water vapor erupting from Europa's surface. This tantalizing evidence points to dynamic geological activity and furthers the intrigue surrounding this mysterious moon. In November 2019, an international team led by NASA made a groundbreaking announcement. For the first time, water vapor was directly detected above the surface of Europa. This discovery was made using a spectrograph at Hawaii's Keck Observatory, which analyzed the chemicals in the atmospheres of other planets by observing the infrared light they emit or absorb. If the detected plumes indeed originate from Europa's subsurface ocean, a spacecraft could potentially fly through them to collect and analyze samples directly from space, much like NASA's Cassini probe did with the plumes from Enceladus, one of Saturn's moons. This approach offers a direct window into the conditions within these distant oceans. To further our exploration, the James Webb Space Telescope employs 2 main instruments: the Near-Infrared Camera, NICAM, and the Near-Infrared Spectrograph, NURC. NICAM, which serves as the main camera and successor to both the Hubble and Spitzer telescopes, excels in capturing crystal-clear images in the near-infrared spectrum. It features 2 components, one for wide-field imaging and another equipped with coronagraphy technology, designed to block out the intense light from stars and planets, thus revealing fainter objects in the background. This technology works similarly to shading your eyes with your hand to see more clearly in bright sunlight, allowing astronomers to study dim and closely located celestial objects. NICAM's coronagraphs are particularly adept at studying the environments of star systems by blocking out the bright light from the central star, allowing researchers to focus on less luminous nearby objects. Meanwhile, the Near-Infrared Spectrograph, NURC, examines light in the 0.6 to 5 microns wavelength range, converting it into a spectrum that reveals vital details about an object's temperature, mass, and chemical composition. These tools are pivotal in expanding our understanding of the universe, from the earliest stars and galaxies to nearby star systems and objects within the Kuiper Belt. The James Webb Space Telescope, launched in December 2021, represents a significant leap forward in our quest to understand the greater cosmos. Designed to be the premier observatory of the next decade, JWST studies every phase in the history of our universe, from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth. During a continuous 10-hour observation period, JWST focused its powerful instruments on a distant exoplanet located in the habitable zone of its star system. This zone, often referred to as the Goldilocks zone, is neither too hot nor too cold, allowing for the potential of water, a key ingredient for life as we know it, to exist in liquid form. Scientists were astounded to detect unusual patterns of chemical signatures in the atmosphere of the observed exoplanet. These signatures included a complex mix of organic molecules and variations in gases that, on Earth, are typically associated with biological processes. The presence of methane spikes and fluctuating oxygen levels particularly piqued their interest. The detection of these chemical anomalies is groundbreaking. It suggests that biological processes, possibly similar to those on Earth, may be occurring on other worlds. This discovery could redefine our search for life, focusing on planets and moons within the habitable zone and analyzing their atmospheres for similar chemical signatures. With this new data, the James Webb Telescope will continue to observe the exoplanet, along with others in similar environments, to gather more evidence and potentially confirm the presence of life. This pivotal discovery will likely steer future missions and focus on exploring these distant worlds more extensively. Technological advancements have been pivotal in our quest to understand the cosmos. The James Webb Space Telescope itself is a marvel of modern engineering, equipped with a suite of scientific instruments designed to capture light from the early universe. These instruments allow scientists to peer back in time over 13.5 billion years to observe the formation of the first galaxies. The data collected during the JWST's 10-hour observation is complex and abundant. Scientists use sophisticated algorithms and models to interpret the light spectra obtained from distant exoplanets. This process helps them identify the chemical components of these worlds' atmospheres and determine if they could potentially support life. This discovery was not made by a single entity or country. It represents a collaborative effort involving multiple nations and hundreds of scientists and engineers. This teamwork exemplifies how global cooperation can lead to monumental discoveries that benefit all of humanity. The potential discovery of extraterrestrial life has significant implications, not just for scientists, but for the public as well. Educational programs and public outreach are essential to help everyone understand the importance of these findings and the science behind them. These programs also inspire the next generation of astronomers and scientists. The discovery of potential life outside Earth poses profound philosophical and ethical questions. What does it mean to be alone or not in the universe? How should we treat other life forms, should they be discovered? The answers to these questions will require thoughtful dialogue across various disciplines. Discoveries like these underline the importance of continued funding and support for space exploration. With adequate resources, future missions could be designed to specifically search for signs of life, potentially leading to even more groundbreaking discoveries. As we search for life in outer space, it's a poignant reminder of the importance of protecting our own planet. Understanding the delicate balance of life supporting conditions on other planets highlights the need to preserve Earth's environments and ecosystems. Following this potentially revolutionary finding, the James Webb Space Telescope will focus on several similar targets. Each observation helps to refine our understanding of what makes a planet potentially habitable and guides future exploratory missions. While it's important to await further evidence before drawing definitive conclusions, the scientific community is abuzz with speculations and theories about what life on another planet could look like. These discussions spark imagination and innovation, driving further research and exploration. The success of the James Webb Space Telescope has spurred plans to enhance its instrumentation and capabilities further. Engineers and scientists are already discussing upgrades and additional tools that could be added to JWST or future telescopes. These enhancements will focus on increasing sensitivity to detect even fainter biological signatures from far-off worlds. Artificial intelligence, AI, plays a crucial role in interpreting the vast amounts of data that space missions like JWST generate. AI algorithms can identify patterns and anomalies in data much faster than human researchers, speeding up the process of discovery and allowing for real-time analysis during observations. As we venture further into space and potentially encounter forms of life, international laws will need to evolve. Currently, space law primarily covers satellite deployment and debris management, but the discovery of extraterrestrial life will require new frameworks for biosecurity and interplanetary contamination prevention. The potential discovery of extraterrestrial life has always had a significant impact on popular culture, inspiring movies, books, and art. This latest discovery by JWST continues to fuel the imagination of creators around the world, influencing new works that reflect our hopes and fears about what lies beyond our planet. While scientists have theories and expectations about what they might find in space, the true nature of the universe often surprises us. Preparing for the unexpected means staying flexible in our scientific pursuits and being ready to pivot based on new discoveries, no matter how challenging or unexpected they may be. In addition to space telescopes, Earth-based observatories play a vital role in astronomy. Strengthening these facilities and their capabilities can provide a dual approach to observing the universe, combining data from both space and the ground for a more comprehensive understanding. Continuous learning and adaptation are essential in the field of astronomy. Each discovery provides new knowledge that can refine or overturn existing theories. For scientists and enthusiasts alike, staying educated and informed about the latest research is crucial to understanding our place in the universe. Public interest and community involvement are vital for the continued support and funding of astronomical research. Events like stargazing nights, public lectures, and educational workshops can engage the community and spark interest in the next generation of astronomers. As we potentially inch closer to discovering extraterrestrial life, planetary protection becomes increasingly important. This involves procedures to prevent contamination of other worlds by Earth life and vice versa, ensuring that future scientific discoveries remain valid. The search for extraterrestrial life is not only a pursuit for astronomers, but also for biologists, chemists, and philosophers. Expanding interdisciplinary collaborations can provide new insights and approaches, merging different scientific perspectives to tackle the complex questions that arise from these discoveries. Communicating across the vast distances of space is a challenge that requires ongoing advancements in technology. As we prepare for missions that might involve direct or indirect interactions with extraterrestrial life, improving our ability to send and receive signals over these distances becomes crucial. As the possibility of encountering extraterrestrial life becomes more realistic, ethical considerations must be addressed. This includes debates on whether and how to communicate with non-Earth life forms. Developing a set of ethical guidelines for these interactions is essential for conducting responsible and respectful space exploration. Sustained funding is crucial for the future of space exploration and astronomy. Public support and understanding can drive governmental and private investment, which in turn fuels further discoveries. Advocacy and education about the importance of astronomical research are key to securing these resources. Citizen science projects in astronomy allow anyone with an interest in the stars to contribute to real scientific research. Projects like exoplanet hunting and galaxy classification are more accessible thanks to online platforms, enabling volunteers to make significant contributions to the field. As we continue to send instruments and satellites into space, addressing the issue of space debris becomes more urgent. Ensuring that our pursuit of the stars does not create an unsustainable environment around our planet is crucial for the safety and success of future missions. Understanding how our ancestors viewed and interpreted the night sky gives us insight into the human relationship with the cosmos. Reflecting on these historical perspectives can inspire a sense of wonder and continuity in our ongoing quest to understand the universe. Innovations in telescope technology, such as adaptive optics and next-generation materials, continue to revolutionize our ability to observe distant objects in space. These advancements not only enhance our current capabilities, but also shape the future design and deployment of telescopes. Education and training for the next generation of astronomers are vital. By investing in STEM education and providing hands-on opportunities, we can prepare young scientists to continue the work of exploring the universe and solving its many mysteries. International space stations like the ISS play a crucial role in preparing for deeper space exploration. These facilities not only serve as test beds for technologies, but also help us study the long-term effects of space on humans, crucial for planning missions that might interact with extraterrestrial environments. As we contemplate missions that could bring us into contact with extraterrestrial life, the evolution of spacesuits becomes increasingly important. Modern designs focus not only on protecting astronauts from the harsh conditions of space, but also on preventing any biological contamination during potential encounters. Public interest in space exploration has waxed and waned over the decades, but discoveries like those from the JWST can reignite excitement and support. Engaging the public through media, interactive experiences, and education helps maintain the momentum needed for sustained space exploration efforts. Astrobiology, the study of life in the universe, has transformed from a speculative field to a central scientific discipline in space exploration. This field combines geological, biological, and chemical science to understand the potential for life on other planets. Our solar system still holds many secrets, from the icy oceans of Europa and Enceladus to the methane lakes of Titan. These bodies could also harbor life and are relatively closer to explore and study, providing a practical focus for future missions. Robotic explorers, such as rovers and drones, are invaluable in the search for extraterrestrial life. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching, subscribe, like, and share. Don't forget to leave your comments.